This is 3.4a notes, mean and standard deviation of frequency distributions. So first of all, notice that we're dealing with only mean and standard deviations. So we just went through a whole bunch of measures of central tendency. The mean is the one we're going to use the most in this class, almost exclusively what we're going to use in this class. We also went over a whole bunch of measures of dispersion. The standard deviation, so variance and standard deviation, don't forget they relate directly to each other. Those are the ones that we're going to use almost exclusively in this class. Okay. So for this chapter, you will need to know the others, but for future chapters, all you need to know is the mean and the standard deviation. Okay. Now we're dealing with frequency distributions. So I just want you to see what that looks like. So if you go down to example number 1 here, or example number 2, either one, you can see I have x, that represents my data points, my actual values. Then I have f now, that represents frequency. A frequency is how often it occurs. How many times does this value happen? Okay. So 3.4a, we're just going to go through these pretty quickly. So we have sample versus population. Important distinction once again. My sample mean is x bar, and that is the sum of xf over the sum of f. We actually did this in 3.2. That should look familiar. Now we're adding in variance and standard deviation. For variance, we're relating it to the sum of squares method, the last thing we did, because you can't really do the other one. Okay, so it's the sum of x squared f minus the sum of xf squared all over the sum of f all over the sum of f minus 1. Notice we have that correction factor. Okay, standard deviation is the square root of variance. Then we get population. Population mean is mu, sum of xf over sum of f. That should look familiar. Once again, it's the same thing as the sample. The only difference is which type of data set. Sigma squared. So sigma squared, that's our population variance. So sum of x squared f minus the sum of xf then squared over the sum of f all over the sum of f. So this one does not have that correction factor. So we just have the sum of f, not the sum of f minus 1. Okay, and sigma, the standard deviation, is the square root of the variance. Okay. So one thing to notice, the formulas are very similar. We just have f's now. So sum of xf, that's the adding up of all my data points. The n is replaced by the sum of f because we add up our frequencies. That's how many data points we have total, which represents n. So they're really the same thing. They're direct replacements for each other. Just in this case, because we're going to be dealing with frequencies, I have in the formula the sum of f instead of just n, because people get confused with that sometimes. All right, so first one, we have sample data. Okay, first thing you do, makes things a lot easier, is to actually fill out the formula or the table. So we have all the data points and the corresponding frequencies. Then I add on 2 columns, x times f, multiply x times f. So 3, 8, 27, 24, 10. Just multiplying them, okay? Then the other column we add is x squared times f. Okay, so this is one where people get thrown off. So you got to be really careful. We're not squaring both. So we're not squaring this column. We're only squaring the x. So we can actually take this column and multiply by the x one more time. So I get 3, 16, 81, 96, and 50. Okay, because I have 2 x's, x squared times f. Or you can just actually use a calculator, do x squared times f, x squared times f, and you get the same value. Okay, so this is a formula you're following basically. Be careful, don't just assume you're squaring this column, because notice they are not squared. It's only the x is squared, then you multiply by the f. Okay, and we need 3 sums. Okay, notice we have 2 of them we use in the mean, and then we have 3 that are in the variance. Okay. Sorry, I should be talking about the sample data because we're dealing with sample, but the same idea. Okay, so sum of f, add up all the frequencies. This is the total number of data points I have, 24. Sum of xf, add up the xf column. This represents the sum of all the data because we're taking each data point, multiplying by its frequency, and adding them up. So it's the sum of all the data. The last one, sum of x squared f. So we add up that last column, and that is the sum of all the squared data points. Okay, so once we have that, we can find our pieces, mean, variance, and standard deviation. The mean is the sum of xf divided by the sum of f. So I have a mean of 3. Sample mean is x bar, so make sure you're using the correct variable. Then I have a sample variance, s squared. Okay, so I'm following this. So it's the sum of x squared f, which is 246, minus the sum of xf, then squared, divided by the sum of f. So that's 72 squared divided by 24, all over the sum of f minus 1. So 24 minus 1. Okay. So you use a calculator at this point. Please actually practice using your calculator once again. So make it look exactly like the top. So 246 minus 72 squared divided by 24. Okay, so that's 30. It's the top. Divided by 24 minus 1 is 23. So I divide 30 divided by 23. And I get, rounding to the nearest tenth in this case, 1.3. So that's my sample variance. And then the last thing is my standard deviation. Oh, running out of room a little bit, so we'll go up here, which is the square root of variance. So that one should be easy. Square root of that. And you get 1.1. Okay, there we have it. Number 2, population data set. But really we go through the same steps. The only difference is the formula for variance. Everything else is exactly the same. So the first steps are the same. So multiply. 12 times 11 is 132. 10 times 5 is 50. Okay. Then we have x squared f. So I square the first column and then multiply by f using a calculator if you need one. Notice we're going to be dealing with larger numbers this time. But since you have a calculator, it should not matter. Use a calculator. You can use your phone calculator if you need to. Okay, so get our 3 sums. Add up all the frequencies, 26. Add up all the data, which is x times f, 228. And then add up the squared values, 2304. Okay, now we're finding population, so make sure you realize that. Use the correct equation, so the mean is mu, 228 divided by 26, which is 8.8. The variance is sigma squared, that is the squareds minus the sum of the non-squareds squared, so 228 squared, divided by the sum of f, all over just the sum of f in this case. Okay, so we use our calculator to add up that top portion. Make sure it looks like what it looks like on your paper. As long as it looks like that, you should be good. So the top, you don't really want to round, but just to give you an idea of what you should get on the top, about that. And then use that whole exact value and divide by 26, and we get the 11.7. So my variance is 11.7. And finally, we take the square root of that, and we get 3.4. and that's my standard deviation. Okay, make sure you're using the correct variables. Sigma is standard deviation, sigma squared is population, sigma is population standard deviation, sigma squared is population variance, mu is population mean. You might be able to start recognizing right here, if you look at the population versus the sample, population is using Greek letters, sample is using our normal letters, X and S, right? This is mu and sigma. All right, the last one. We have a sample data set again, find the mean, variance, and standard deviation, but we have a slight difference. In our data, that's the age, our age here is the data, is a range of numbers. Okay. Basically, if you're given a range of numbers, you need to use the middle value. Okay, you can have a couple ways. You add them and divide by how many there are. So we have two numbers on each one, divide by 2. It's the mid-range, basically. So that's 8 divided by 2, which is 4. Or you can see the pattern. If there's 4 numbers in between, I'm going to go 2 to find the middle. Okay, so either way, you can add them up and divide by 2, or you can just look at and see the pattern and go right in the middle of the 2. Okay, it will be the same no matter what. So we have 4, 8, 12, 16, and 20. And then those frequencies, the next column, relate to our new values. Okay, we can't use a range, so we have to use a value, a single number that represents the range. So 2 to 6, the average of that is 4, so that's what we use. So 2, 10, 12, 9, and 7 are my frequencies corresponding to those same values. Okay. Then we just go through our normal steps. So I'm multiplying x times f. Next, I'm squaring the x times the f. You probably want to use a calculator for this one if you don't know how to do it, because these get much larger values. Okay. And then I'm finding my 3 sums. Okay, so sum of f, that's the total number of data points I have, sum of the frequencies. Then the sum of the data is the sum of x times f. And then finally the sum of the squared data, which is sum of x squared f. Okay, and we use our same formulas. This time it's sample, so make sure you're careful about that. So 516 divided by 40, 12.9 mean. My variance is s squared, because we're using the sample, because this is a sample. It's the squared data minus the non-squared data, then squared, divided by the total number, all over the total number minus 1. Okay, so use your calculator, do the top, then divide by 39, and you should get 21.7. Please actually practice this, right? You don't want to be using your calculator the first time when we take that test. Okay, so we just take the square root of that whole thing, and we get 4.7 as our standard deviation. So S, our sample standard deviation is 4.7. S squared, our sample variance, is 21.7. And X bar, our sample mean, is 12.9. Okay, so that's looking at mean and variance and standard deviation when we have frequencies given, not just single data points listed, right? We have a data points and the frequency listed. Okay, so make sure you write your 3-sentence summary.